Hi everyone, I'm Liu Jiahao, the group leader of Group 6. Today, I would like to present a complete design of an IPv6 only university campus network. This project is developed for a newly built international college with the goal of building a secure, scalable, and high-performance network infrastructure. It can fully scientific, present operational demands, and support future expansion. Now, let's move on the specific detail. Our presentation consists of four main parts. To start with, we will introduce the project background and core functional requirement. Next, we will elaborate on the overall network architecture and corresponding design scheme. After that, we will talk about deployment procedure and relevant device configuration. Last but not least, we will demonstrate our verification and test outcome to verify the network's normal operation and security protection capacity. Now, let's move on the project overview. Our primary objective is to construct an IPv6 only campus network for this newly built international college. The network must feature robust security, support a 30% expansion of end users, and maintain high transmission efficiency. Our design scope covers all critical campus zones such as computer laboratories, teaching room, administrative office, and student wireless Wi-Fi connect. Now, let's go through our strict code requirement. To begin with, the word network shall run exclusively on the IPv6 protocol. Secondly, internet access will be provided to a 1 Gbps fiber uplink. Thirdly, logical IPv6 subnetting is adopted to isolate traffic across different campus zones. Fourth, comprehensive security policies and strict access control are compulsory. Last of all, the design is future-proof, capable of accommodating a 30% growth in the number of campus users.
Hello, my name is Sarah and I'll be presenting the network architecture and design. So we went with the three-tier hierarchical model. Let me break it down. The first tier is the access tier. This is where all the end devices connect: your student's PC, instructor machine, servers, wireless clients, everything plugs in through Cisco 2960 switches. Above that is the core layer, the high-speed breakbone. All traffic from access switches flows up here. It keeps communication between different parts of the campus fast and organized. And the top is the edge layer, one Cisco 2911 router that connects our entire internal network to the ISP, TM, and IT through a 1 Gbps fiber link. This is also where we ensure security before anything leaves the campus. The reason we chose this model is simple. It keeps things clean and scalable. If something breaks in one lab, it doesn't affect the rest of the network. And adding new devices in the future just means plugging into the access layer. No need to redesign the whole thing. Here is our full network topology. At the edge, you got R1, our Cisco router, connecting to the simulated ISP on the right. Everything internet bound goes through R1. Behind the core switch, this is the heart of the network. Everything on zone on campus connects back to this single point: the computer labs, classrooms, admin office, server, room, and wireless network. From the core switch, separate access switches branch out to each zone. The layout may look busy, but the structure is actually very straightforward. Any device follows a clear path: access switch, core switch, router, internet. We kept this topology deliberately simple, which aligns with the project requirements for easy troubleshooting. If there's connectivity issues, you can trace it tier by tier without guesswork.
Good morning, everyone. Now I will continue with part 3, which is the implementation and configurations details of our IPv6 university campus network. Instead of referring to the slides, I will demonstrate using our packet tracer topology. First, this is our complete network topology. Our network is divided into different departments, including Computer Labs 1, Computer Labs 2, Classroom, System Administration Office, server room, and also a wireless network. Each department has its own IPv6 subnet to separate the traffic and make the network easier to manage. Next, I will explain the core device of our network. In our implementation, we use the ISR4331 router as the core device. It is located in the center of the topology and connects all departmental networks together. This router is responsible for forwarding IPv6 traffic between different subnets and ensuring that every department can communicate with each other. Here we can see that multiple IPv6 interfaces have been configured with one interfaces connected to each department. Every interface acts as the default gateway for its corresponding subnet. For Computer Lab 1 and Computer Lab 2, each lab has its own access switching connecting the PCs. The client receives IPv6 addresses automatically through DHCPv6, making the network easier to manage without manual configuration. The classroom network is configured in the same way. It has its own subnet and allows students to communicate with other authorized devices inside the campus network. The system administration's office has full network access. The administrators can access all internal servers and also the internet for network management purpose. The administration office is more restricted. Based on the project requirements, these users are allowed to access internet service like the web server and file server, but internet access is blocked using IPv6 ACL. For the wireless network, students connect through this wireless access point using laptop or smartphone. Similar to the administration office, wireless user can access internet service but are restricted from accessing the internet according to our security policy. This is our server room. It contains 3 important servers. This is the web server, which hosts the university website. This is the file server, where students can download learning materials. And this is the DNS server, which translates domain names into IPv6 addresses so users can access the services using friendly names instead of remember IP addresses. For the wireless network, students connect through this wireless access point using laptop or smartphone. Similar to the administration office, wireless user can access internet service but are restricted from accessing the internet according to our security policy. This router connects our campus network to the internet. A default IPv6 route is configured to forward external traffic to the ISP. At the same time, IPv6 address access control lists are applied to block internet access for a selected department while still allowing access to internal services. Here we can see the ACL rules that deny internet access for specific IPv6 subnets while permitting other traffic. This router connects our campus network to the internet. A default IPv6 route is configured to forward external traffic to the ISP. At the same time, IPv6 address access control lists are applied to block internet access for a selected department while still allowing access to internal services. Here we can see the ACL rules that deny internet access for specific IPv6 subnets while permitting other traffic.
Okay, thank you. Hi, I'm June, and right now I will demonstrate the validation and testing result to verify that our network is functioning according to project requirements. First, I will test the connectivity from Computer Lab to our internal web server, and here I will choose from Computer Lab 2 and I choose PC3. And then we go to the desktop tab, we choose command prompt, and then we type the command ping www.www.com. Okay. And then we wait for the result. Here is the ping is successfully with 0 packet loss. Then this shows that DNS resolution and internet communication are working correctly. Next, I will test the internet connectivity. So we still use the same PC, and then we type ping www.internet.com. So we wait for result. Okay, since the Computer Lab network is allowed to access the internet, all packets are successfully received. So this confirms that routing between the campus network and the ISP is functioning properly. Okay, we close it first. Then now I will testing from administration office. It's from here. So I will choose PC9. So we go to the desktop tab, command prompt. So we type the command. So we wait for result. Okay. According to our security policy, this department is not allowed to access the internet. So here you can see the result saying unreachable. So as we can see, the ping request failed, which proves that our IPv6 ACL is working correctly. Then we will test the internal server. So we're still using the same PC, but we type the command ping, and we wait for result. And here you can see the result is the ping is successful with 0 packet loss. So it's saying that although internet access is blocked, user can still access internal resources like our web server. So this is exactly the behavior required in our project specification. Then we will do another test. So from here, we will test here wireless network. And here I will choose laptop 0. I press it. Then I'm still using desktop tab and then command prompt, and I type the command as you can see, the various users are able to connect to internal service successfully. And then we test from the web server. Use desktop. Desktop. Oh, we use service. No, sorry, we use service, and then it will show that the HTTP is on. And then, as you can see here, is our web server. The HTTP service is enabled, allowing user to access the university website. Then we look for the DNS server. Then we go to service, and then we go to DNS. So as you can see, this is our DNS server. It store the domain name records that allow user to access service using names such as www.inweb.com instead of remembering IPv6 addresses. And then the final one is the file server. And then we go to service, and here we choose FTP. Okay, and here, as you can see, here is our file server. We store teaching materials and file that can be accessed internally. Okay, I close it. Then and zoom out first. Okay. Based on all these testing results, we can conclude that our IPv6 campus network has been successfully implemented. Communication between departments is working correctly, and internal services such as web server, file server, and DNS server are accessible. Internet access is correctly controlled using IPv6 access control list according to the project requirement. Overall, the network is functioning as designed. And that's all from us. Thank you for your patience.